Hello everyone, welcome to our channel. In this video, we discuss exercise 1 problems, first question and second question. Later videos we can discuss remaining questions. Let's get into the video.
To first question, read this question. Express each number as a product of its prime numbers. In this question, what they ask: find factors for 140. 2 sevens, 0. 2 3 6. 1 is remaining, so put here 1. 2 fives, and it's not the factor of 2 and 3. 5, because in units place 0 or 5, it is a factor of 5, so 5 sevens. 7 is also a prime factor, so 7 ones. These are the factors for 420. And multiply those factors into 2, into 5, into 7. These are the prime factors. Find factors for 156 and product of those factors. 156. It is a factor of 2, so 2 sevens. 1 is remaining. 2 sevens 14. 1 is remaining. 2 eights 16. Next 2 3 6. 1 is remaining. 2 nines 18. It is not a factor of 2, so because in unit place there is no 0 2 4 6 8, and it is not a factor. So next, add these terms. 9 plus 3 12. 12 is in by 3, so 3 ones 3 threes, 3 ones 3 threes 9. Next, 13 is also a prime factor, so 13 ones. These are the prime factors for 156 and the product of those terms. 156 equals to 2 into 2 into 3 into 13. Solve and comment on the answer for it.
Check out the answer. Find the factors for 5005 and product those factors. 5005. In units place 0 and 5 is there, so it is a factor for 5. 5 ones, 0 0 5 ones. It is not the factor for 2. Sum these terms. 1 plus 1 2. 2 is not in a 3 table, so it is not a factor for 3. 5. In units place there is no 0 and 5, so it is not a factor of 5. And next, prime number 7. 7 may be divisible, so 7 ones. Remaining 3. 7 fours 28. Remaining 2. 7 threes 21. So it is not 11 ones 12 13 3. 3 remaining. 11 threes 33. 13 is a prime number, so that it's a 13. Product of those terms. 5 into 7 into 11 into 13. Find the factors for this 7429. Prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19, 21. 21 not 23. First, 2 is not possible because in units place there is no 0, 2, 4, 6 and 8. Move to 3. 9 plus 7, 16. 16 plus 2, 18. 18 plus 4, 20. 21, 20. 22 is not in 3 tables, so it is not possible. Next, 5. In units place there is no 0 and 5, so it is not possible. 7. 7 ones, 7 6 9, it is not possible, so move to another one. 11. I think so. 11 13 is also not possible. We will check 17. 17 468. 4 plus 2 6. 7 3 is 51. 9 plus 2 10 11. 17 sevens 119. Next, 19. 19 twos 3s. 23 is a prime number, so 17 19 23 is a factors for 7429. Product those factors. 17 into 19 into 23. Read the question. Find the LCM and HCF of the following pairs of integers and verify that. Using this equation, LCM into HCF equals to product of the two numbers. First, step 1, we do the prime factorization for 26 and then find the prime factorization for 91. Next, find LCM and HCF. Multiply these numbers. First, step 1. 2 ones, 2 threes. 13 is a prime factor, so 13. factors of 26. 2 into 13. Next, find prime factorization for 91. 2 is not possible. Next, 3. 9 plus 1, 10. 10 is not possible. Next, 5 is not possible. 7. 7 ones. 7 may be possible. 7 ones. 9 minus 7, 2. 3. 7 3 is 21. 13 is a prime factor, so equals to 9. What are the prime factors for 91? 17 into 13. Next, find LCM. Multiply the highest powers in those two numbers. 2 is the highest term among 26 and 91. 2. Next, highest term, highest power 31 in both. So anyone is considered 13. Next, in this 91, 7 is the highest power among this 26 and 91. So multiply 7. 13 to, sorry, I can't record the video, so I will explain again. In this 26 and 91, 13 is common in both 26 and 91. Which is the lowest power? 13 power 1, 13 power 1. So anything is fine. 13 is a HCF. Verify that. In question. What is the LCM into HCF equal to product of two numbers? What is LCM? 182. HCF 30. What are those two numbers? 26 and 91. And product 26 into 91. 2366 is the answer. 26 into 91 is also 2366. So LHS and RHS is equal, hence verified. Solve this. Hope this video is helpful for you.